Now that we have learned how to generate the B scan, we can move on to generating an A scan. The first thing that you have to do is determine where we want to cut in the cross-range axis. For example, let's open this image. We want to cut at, for example, exactly 10 inches. So the B scan is made up of a finite number of A scans along this axis. And we want to cut at 10 inches to see the A scan plot exactly here. So, by the way, you can also use the graphical user interface to change a lot of stuff that you can actually also change with the code. For example, we can insert the color bar or hide it. And you can change the location, you can change the color map. So we want to cut it at 10 inches. But we have to actually transform this 10-inch to a pixel value because the image is a matrix of pixels and it does not recognize 10 inches. So we use a simple interpolation to do that. We have to transform inches to pixel. So how do we do that? We know that the GPR distance is 20. And at the end here, the GPR distance is 40 and 44. And at 44 inches, we know that A, the value of A here, which corresponds to the cross-range axis, has a value of A. So we know that the image is from pixel 1 to pixel 887 in this range, right? So we know that at the end, which is 44, it corresponds to the pixel number 887. So how about we want to know the A cut and turn it into pixels. For example, we can call it A cut pix. Therefore, we can find A cut. So we determine the cut in inches. Now we have to turn it into pixels. Now using this interpolation, we have so let's leave the semicolon off to see what the value is. So as you can see that this is not an integer number. What is the name again? As you can see that the class of this A-scan pix value is a double. And pixels cannot be double values. There should be integer values. You cannot say that I want to cut at exactly 201.59 pixels. This does not exist. So we have to use the round function to actually round it into the closest natural number. which is 202. Now we are ready to plot. You can call it a scan equals plot. We want the x-axis to be our amplitudes, but we want it to be at a scan pix. We want it to go through all the range from here to here, from 0 to 200 to 20 inches. And then we want the y-axis to be the range. Okay, I think my MATLAB is frozen. I have to close it and open it again. So as you can see, the workspace is clear. So we have to run everything to load the variables into workspace again. Unrecognized functional variable. Okay, the name was a cut pix. You can see we have the A scan, but there's some changes that we can make to make it better. For example, we can actually change the aspect ratio. We can change the lawn width, the color, and we can give it labels, titles, and subtitles. But the most important thing that we understand from this plot is that we want it to start from 0 to 20, but here it starts from 20 to 0. So we have to reverse the y-axis. Again, using the GCA handle, we can change the y direction to reverse. And again, we can do it the second way. For example, you can use the get function to get the GCA, and then we can use dot indexing to change the axis direction. So both of these are just fine. You can change using any of these syntaxes that you want. There are different ways to do one thing in MATLAB, and that's why it's very flexible. Okay, let's give it X label, amplitude, Y label is depth. We can also give it a title. For example, a scan. We can also give it a subtitle. For example, cross range cut equals a cut, which is in inches. And also change the font again. You can also change the line width. To 2. As you can see, there are many things that you can do here. For example, we can change marker, we can change a lot of stuff. I will leave it to you to explore it. And also determine the color, for example, red, and use continuous lines. Okay, this one is changed. I think we should put it here. Okay, now it's great. For example, we can change this to look like this. We can change the color. There is a list, complete list in the documentation. Now, this still doesn't look right. We can use the GCF position handle to make it look like this, which is actually more comprehensive. And you can see the direct coupling here. So let's use the GCF handle. Position. Again, remember, this is X position, Y position, width, and height. Now, this looks much better. We can also change the amplitude here. For example, just like the color again, the C-axis that we change here, so we can interpret the results better. We can also play with this one here. For example, we can change it to -10. 10. You can make it smaller. So this is how we can perform an A-scan in any range that you want. For example, we want the A-scan at 20 inches. Let's try now. Now this is your A-scan at 20 inches. This is at 5 inches. And you can do this as much as you like.